memory location only. That is continuous memory allocation. Then in that we have two schemes. One is fixed size partitioning, the other one is variable size partitioning. In fixed size partitioning, we have converted the big memory piece into a small chunk. A memory is divided into small chunks of fixed size. But please note that it is not necessary to have the block size as same. Okay. So that I have illustrated with the help of three algorithms: first fit, best fit and worst fit. The definition of first fit is you should start assigning from the first available block. Then best fit says select the smallest available block that can accommodate that process, and the worst fit says select the largest block which is going to accommodate that particular process. So that I have illustrated with the help of the numerical example. So I hope this part is clear. This completes the contiguous memory allocation. So the expected questions on this is you need to understand these three algorithms and practice more and more problems. Sir, modification madam. It is.
ಕನೆಕ್ಟ್ ಕೊಟ್ಟೇರಿ ಇದಾಗಿದೆ ಬರೀ ಕಂಪ್ಯೂಟರ್ ओके ऑफ झालं कंप्यूटर ऑफ USB झालं मॅल करू हां प्रेस आठव अरे इले म्हणजे इकडे कुठे हे आहे का बघा डिस्प्ले खरे खरं डिस्प्लेचं इकडे कुठं तरी भेटून केलं हां आलं आलं बघा आलं ಇಲ್ಲೇ ಬಟನ್ ಅದರ ಡಿಸ್ಪ್ಲೇ ಬಟನ್ ಅದ ಇದು ಇದು ಬಂದಿದ್ದು ನೋಡ್ರಿ ಇದು ನೋಡ್ತೀನಿ ಪಿಪಿಟಿ ಕರೆಕ್ಟ್ ಆಗ್ತದೆ ರಿಮೋಟ್ ಇದೆ ಇಲ್ಲ ರಿಮೋಟ್ ಹಾಂ ಪಿಪಿಟಿ ಓಪನ್ ಆಗ್ತದೆ ಪಿಪಿಟಿ ಅಲ್ಲಿ ಲ್ಯಾಪ್ಟಾಪ್ನಲ್ಲಿ ಡಿಸ್ಪ್ಲೇ ಅಂತೂ ಅದಕ್ಕೆ ಕರೆಕ್ಟ್ ಕನೆಕ್ಟ್ ಅದಕ್ಕೆ ಜೊತೆ ಡಿಸ್ಪ್ಲೇ ಬಂದಿದೆ ಲ್ಯಾಪ್ಟಾಪ್ದು ಬಂದಿದೆ ಥ್ಯಾಂಕ್ ಯು ಸರ್ ವೆರಿ ಮಚ್ Good morning students. Today we are going to start with chapter software testing part 2. I think in the last class we have covered the introduction regarding about software testing, a definition of software testing and different types of software testing like white box testing and black box testing and their particular examples. So these all the topics we have covered up to till now. So these are the topics covered in the previous lecture. So today directly we are going to start with stages of testing. In testing, what are the hierarchical structure and what are the different types of testing modes? In what particular level we are going to take care of the testing, as well as what are the different levels of testing deployment when you are going to develop an application or software. So that we are going to study today. And the development testing, where the system is tested during development to discover the bugs and defects. As per the whenever we are going to check whether the particular product is going to meet a functional and non-functional requirements, that we have to check. The functional requirements means what exactly the functionality of the application, whether it will meet all its functionality, whether it covers all the functionality which is we are going to the customer expect from that particular the product. And non-functional means reliability, security and emergent properties, whether it is going to the product is going to meet all the emergent properties or not. And release testing, where the separate testing team tests a complete version of the system before it's released to the user. And the next one is user testing, where user or potential user of system, that the system in their own environment, like alpha testing and beta testing. And the development testing includes usually all the testing activities that are carried out by the team who is responsible for developing that particular system. Means the tester of the software is usually, he is the programmer and who develops the software. The developer himself, he is the tester. He is going to test because according to the specification is done by the developer. So that's why he is responsible for the testing that particular product. Some development process they are going to use tester and programmer paid. Means tester and programmer, it is a parallel activity. For example, you can take agile process. Whenever you are going to develop any product under agile method, where the tester and developer, they are going to work in terms of team, not individually. They are responsible for developing and testing. They are going to coordinate their activities. They are going to combine their particular testing process and developing process. If the development of the one particular version is done, okay, immediately it is going to hand over to the tester. He is going to test that particular the product whether it meets functional or non-functional needs. And in that particular development testing, it is going to divide it among three steps. One is unit testing, second one is component testing, third one is a system testing. This is what we call hierarchical structure, hierarchical levels, one after another. First we are going to, as a developer, I am responsible for carrying out unit testing. Once it is covered, immediately I am going to start with the component testing. Once it is over, we are going to check a system testing. So this is what, whenever the development is over, we are going to deploy these are step by step. And in unit testing, what happens where individual program units, okay, what exactly these individual program units? You can take an example of Java. Java is a collection of different J units. Means each and every module we are going to check. Okay, whenever we are going to define one software product, it is a different versions, different components. Components, what it represents? Different functionality, for example. Okay, you can take a calculator example. Calculator is the product which contains different operations. Add, multiply, subtraction, right? Add is a function. It is a one individual unit. It is responsible for addition, like subtraction, multiply. So the combinedly what we called a calculator, but their individual operations, what it is going to carry out. When you write a program for the calculator, the individual functions which are responsible for their assigned activity, that is what we called unit testing, where individual program units or object classes are tested. And unit testing should focus on testing the functionality of the objects or methods. Next, component testing, where several individual units they are integrated to create a composite components, because the software application is a different discrete collection of different components. Maybe these, once all the individual components are ready, the next question is how to integrate, how to interact, okay, how to create a proper interface in between those particular the components. That is what we called component testing is responsible to connect the components. Component testing should focus on testing the component interfaces. System testing, where some of all the components in the system, they are all integrated. System is tested as a whole instead of individual. See, once you come to the system testing, we are responsible for testing the entire system. We are going to take it as a whole. So that is what, instead of checking individual interactions, we are going to check the entire system and their interactions. Component testing is responsible for testing component interfaces. What is their connectivity? How the functions is available to conduct those activities. So these all the things we are going to carry out by using component testing. But system testing is responsible for testing component interactions. What is the interaction among those particular objects? How they are going to interact? What is their interaction result? What is the function return value? So these all the things programmatically we have to we have to cover all the aspects of the system. So this is what, so these are the three types of testing. So next we are going to study about what exactly the meaning of unit testing. Unit testing is the process of testing individual components in isolation. It is a defect testing process, and unit maybe test all the operations associated with the object. You have to take a Java as a programming language or OOPS as the programming language. It is collection of different objects. Object is nothing but test all the operations associated with that particular object. We have to check individual units. Instead of checking so entire system, just we are going to cover the functionality related with one particular object. Object classes with several attributes and method. Test all the operations associated with one particular object, and object classes. The particular object belongs to which particular class, what is their interface and what is their method, what are the attributes which are going to associated with the object. For example, student is the object. Okay, we have to check the maybe his USN is the one particular attribute, and his the birth date and his particular class number. So these are the what we called object classes with several attributes and methods. Composite components with the defined interfaces used to access their functionality. So these all the things may come under unit testing. First we have to test all the operations associated with that particular object, and object classes with several attributes and their particular method. So we'll go to the example. See, this is object class testing. First, Object class testing is responsible for testing all the operations associated with one particular object and setting and interrogating all object attributes. First we have to check the functionality, testing all the operations. Next, setting and interrogating their particular object attributes. What are the attributes which are assigned to one particular object? Whether those attributes, whenever you change the values, how it is going to behave in a particular environment, that is also a part of unit testing. Next, exercising the object in all possible states. See, for example, you can take a weather station. What happens when it is going to the running state? What happens in the ideal state? How it is going to behave for the environment? How it is going to deploy? So these all the aspects we are going to check by using object class testing, the method. For example, so previously we have discussed the weather station object interface. So here the weather station is the nothing but it is a class. Okay, and under that we are going to define the identifier is nothing but it is the attribute. Okay, weather station is the class and identifier is the attribute which is associated with that particular class. So these are the different methods: report weather, report status, power save, remote control, reconfigure, restart, shutdown. So these are the different methods which are going to associated with a weather station. And next, weather station testing, we have to check for all the instances. For example, shutdown. So already I told we have to check all the attributes and all the possible states, all the interactions, all the functionalities. For example, shutdown, running shutdown. So this is one method. And next, configuration, running, testing, transmitting, running. Next, running, collect. So these all the different scenarios. All these scenarios we are going to check with respect to unit testing. Next one is automated testing is a part of unit testing. So nowadays all the things in the software industry which are automated. So the testing process by using some different tools like Selenium tool, JUnit tool, we are going to simulate all the operations, the particular activities which are going to concerned about the testing. Whenever possible, unit testing should be automated. So the tests are run and checked without manual interventions. The manual testing is manually we have to check, we have to create the operations. We are going to apply some different methods. Then we are going to carry out automated testing. Manual testing. But in automated testing, automatically it will generate the functions, and for those particular functions, we are going to check the condition. If the condition is true, that particular testing is correct. Otherwise, the testing may be false. And unit testing frameworks provides the generic test classes that you extend to create specific test cases. They can be then run all the tests you have to implement it and report often through some GUI. So there are three aspects will come. One is bottom up approach. Second one is top to bottom approach. Another one is a mixture. Bottom up approach means first we have to check the basic things, whatever is implemented by the developer team. Okay. Then we are and in another one, top to bottom approach, first we have to check the primary root of that particular application that we are going to check. So these are the different, in three modes we are going to carry out unit testing with respect to automated testing. So there are very well familiar tools which are available for testing by using automated testing. JUnit for Java programming language, Selenium for web applications. Whenever the client and server is going to interact with the form, so we are going to apply Selenium tool, and Python is also inbuilt for Python programming platform. And there are three phases will come under the automated test components. One is setup part, second one is call part, assertion part. In setup part, first we have to initialize the system function. In call part, we are going to call the objects and associated methods to that particular function. Assertion, we are going to create the condition, maybe addition. The particular mathematical conditions we have to create and we have to check whether it is satisfied or not for the given inputs. Maybe A and B are the given inputs. I am going to check that particular mathematical function will be correctly operated or not. If it is correctly operated, that the result will be yes. Otherwise, it is going to false. So these are the examples: JUnit, Selenium, and Python. Next, we'll come to under unit testing. There are two strategies. One is a partition testing, guideline-based testing. Partition means where you identify groups of inputs, okay, that have common characteristics that should be processed in the same way. Means the collection of data items which are going to collectively they are going to combine. They have logically inherent meaning because the sum collection of data we are going to grouping is done with a plenty amount of data, because in a you can take any web applications or in internet applications, the several in e-commerce applications, the plenty of amount of data will be arrived. It will take a lot of time to test each and every individual unit. So that's why what we are going to do, just we are going to logically grouping of data. Okay, in terms of the large amount of data, we are going to make logically groups. These groups of data, they have some logical relationship. They have some particular mathematical fundamental to group those particular data. So you should choose test from within each of these groups. And so directly I will come to the diagram. So that is what we are, under that particular heading, we are going to study about partition testing. Input data and output results often fall into the different categories, where all the members of class are created. Each of these classes is an equivalence partition. Means the equivalence partition, the main theme is we are going to classify the data as different classes. Equivalence partition. Test cases should be chosen from each partition. See, instead of checking all the data at the one time, we are going to pick only one amount of data. For example, you people are belongs to the CS department. Instead of checking the whether that particular student is belongs to which division, we are going to make 4 divisions. According to what? Depending on your particular roll number. If the student is lies in between 1 to 60, definitely will come to know that he belongs to the A division. Okay, if the student is lies in between 201 to 224, then definitely will come to know that student is belong to the D division. So that logical relationship we are going to apply for the programmatical, the part. That is what we call equivalence partition. So this is what the diagram will explain you, the equivalence partition. And so this is what input equivalence partitions. We are going to, from these input equivalence partitions, we are going to supply the input to the system, then system will check. Okay, there is a one-to-one correspondence in between one particular group to another. For example, you can take Amazon applications. When you visit Amazon application, so it will show you, if you want to buy a laptop, first we are going to visit electronic goods. In that particular electronic goods, the laptop is one logical part. In that laptop, again we are going to investigate, you are going to check your rate convenience. For example, if you want to buy the laptop in the range of 20 to 30,000, only that amount of computers, that logical part will be visible to you people. That is what we call equivalence partitions. In equivalence partitions, we are going to grouping the data in different clusters. Each cluster, what we call a group of data, that will be input to the system. System is execute the correspondent, the particular result. And here the shaded part, what it means, incorrect input. Sometimes as a user, we can make the mistakes, bugs, defects whenever we are going to supply the input. That is what we call incorrect inputs. And this shaded part, what we call exceptions. Exceptions may be sometimes you use it to the particular ATM. Whenever you want to withdraw 75,000, only per day only 45,000 is you can withdraw. So that time, that is what exceptions. Those type of exceptions will be held or fall in this particular shaded area. Possible inputs, correct outputs, and possible outputs. There is a corresponding in between the inputs and outputs. Next, equivalence partition. So already we are going to start. Use the mathematical concept of partitioning into equivalence classes to generate the test cases for functional testing. The key goals for equivalence class testing is, one is completeness of test coverage, lesson duplication of test coverages. So instead of checking the same input again and again, so we are going to group the data from that particular group. We are going to pick one particular slices or one particular piece of data and we have to check. So it coverages the entire set of data. That is what completeness of the test coverage and lesson duplication, minimize the redundancy. Okay, whatever the redundant data, just we are going to avoid, just we are going to particularly we are going to capture on what type of data we are going to simulate. And next I will come to this example will help you to understand what exactly the meaning of equivalence partition. Consider a numerical input variable I whose value may range from -200 to +200. Then the possible partitioning of testing input variable by the 4 people may be. So this is what logically how we people are going to the partition the entire set of data. -200 to -100 is one particular class. -101 to 0 is one class. 1 to 100 is one class. 101 to 200 is one class. If you want to check the numbers in between -200 to +200, it is a very lengthy amount of the data. So that's why that particular data is going to divide it among 4 partitions. Based on what logical we are going to make the partition means depending on same sign. Whatever the number which belongs to negative numbers which falls under one particular class. Again, -101 to 0 is one particular class. 1 to 100 is positive number. 101 to 200 is a positive number. Define the same sign as the equivalence relation or defined over the input variables value set minus 200, 0 plus 200, then one partitioning will be minus 200 to minus 1. See, depending on the negative sign, we are going to carry out one class. 0, no sign. 1 to 200, positive sign. Then now we'll come to the previous diagram. See here, the entire data will be divided among three classes. One is negative numbers, 0, positive numbers. What are the possible output numbers? If I given minus 1, the result will be negative number. If I given plus 10, it will given positive number. 0, there is no sign. So that is what, instead of checking these all the 100 numbers, what I am going to do here, just I am going to give one piece of data and I can check. Then this particular class is valid. Again I am going to check 0, only one number, the class is perfect. 1 to 200, only I am taking one particular value and I can check. That is what three classes are satisfied. So these are the three classes. It will mean completeness, redundancy, minimize the redundancy. So these are the two advantages of equivalence partitioning method. The first one is minimize the redundancy, completeness. So it will complete the entire data and it minimize the redundancy. Instead of checking 100 numbers, so I can check only, I can perform on only one input data and I will conclude the result. What are the result here? This is what input domain, this is what output domain. Output domain covers three classes, negative sign, no sign and positive sign. Input domain is divided among three classes. There is what one-to-one correspondence. Negative sign, there is a one-to-one correspondence. No sign, one-to-one correspondence. Positive sign, one-to-one correspondence. This compatibility what it will give by using equivalence class partition method. We'll come to some testing guidelines. What guidelines we are going to follow while testing one particular application by using equivalence partition method. Test software with sequences which have only a single value, because single value means whenever you are going to supply the input to check whether it is correct or not, we are going to provide only a single value. For example, minus 200 to 100, whenever I am going to provide, it should be a single value. Whenever I am going to check next date function, the next date function we are going to provide the inputs as month, the day and year. It should be, we have to pick any one date from the given 1 to 31 days. That is what a single value we have to supply to check for the testing purpose. Use sequences of different sizes and different tests down dependent on only one particular type of data. Instead of that, we have to check the various, all the possibilities, input possible data we have to supply and we have to check whether it is going to satisfy the given conditions or not. The test with sequence of zeros and length. See, whenever we are going to check any one particular application, so we have to check at the boundaries. Boundaries means, so these are the extreme values, extreme conditions we are going to check. So how to provide that particular extreme condition? See here, this is what diagrammatical approach, what it indicates B. For example, if I want to provide the data in between 1 to 100, okay, it is lies in between. A is the minimum value, 1 I can take. C is the maximum value, 100 I can take. And what is the B means, it is a nominal value, 50 I can take. Whatever the values which is lies in between 1 to 100, that is what we call nominal values within the range, okay. And I want to check C plus means maximum plus, that is the boundary, nearest value for the 100, 101. Minus C, minimum, maximum minus, what is the very near number to the 100 as a minimum, 99. And I want to check here, A is the 1. And what is the minimum plus 2, minimum minus, it is the 0. So these all the inputs we have to provide. So that's why whenever you want to check any one particular applications, we are going to satisfy these all the values. First we have to check at the maximum, minimum, nominal, maximum plus and maximum minus, minimum plus, minimum minus. So these 5 values are very important. One is minimum, minimum plus, minimum minus. B is the value, it is the nominal. C is the maximum, maximum plus, maximum minus. It is going to divide it among 0 to n3. For example, I want to check 0 to 100. 1 to 100. 1 is the minimum. 100 is the maximum. It is my range. Maximum plus 101, maximum minus 99, and minimum plus 2, minimum minus 0. So this is way how these testing guidelines we have to follow for providing the input values for any application. You can take any Amazon, you can take any e-commerce applications. Very simple, you can take very simple calculations. So this is the way how we are going to check the testing the probabilities, okay, whether that particular, all the functionalities, whether it is covered or not, it is going to check by using. So these are some of the guidelines we are going to follow. So directly we'll come to the example. So here we'll study how to define minimum maximum value for that password field cannot be shorter than 4 and longer than 28 characters, numeric and alphabetic. So here the question is, whenever you want to design GUI, graphical user interface design, so first we have to create authentication phase. In that authentications we have to check, okay, whether that particular given password is correct or not. So for that, what they have condition, the password field cannot be shorter than 4, means it's not lies in between 0 to 3 and longer than 28 and not longer than 28. Solution, first we have to identify the range. Whatever the password what we are going to create for your authentication, it should be lies in between 4 to 28. Then what is the minimum value here? 4. What is the maximum value? 28. So for this I want to write the classes. There are 2 invalid classes. There is only 1 valid classes. What is that invalid class? If it is lies in between 0 to 3, what happen? It is invalid classes. If it is lies in between 4 to 28, your password, then it is valid class. If it is beyond 28, means 29 plus 1, so it is an invalid class. So this is the way how to classify equivalence partition your particular data. Because 0 to 3 is the invalid, for this particular we have to write, this is the minimum and maximum. How to write and minimum and minus? What is the minimum value? 0. How to write for minimum? There should be minimum plus, that is 0 plus next 1. What is the minimum minus? It should be minus 1. Again for this particular value, 3 is the maximum, 3 plus 1 is the maximum plus 1, that is the 4. Maximum minus nearest value to the 3 is 2. This is invalid class. Again for 4 to 28, this is the valid class. For this one I can, how I am going to write? 4 is the value, minimum minus 1 3, minimum plus 1 5. 28 is the maximum value, 28 plus 1 29, minus 1 27. Again if it is exceeds 29, we will conclude it as an invalid class. So this is the way how to apply and how to find out a valid and invalid, okay, equivalence partition classes. 0 to 3 is the invalid, 4 to 28 is the valid, 29 plus it is a invalid class. We'll take one more example. The program selects candidates for military service focusing only on the range, on the age, not less than 18, no more than 25. Range, conscription in the army. Not conscription means, it is a very simple. If the age is lies in between 18 to 25, it is a valid. If it is greater than 26, invalid. If it is less than 17, invalid. There are 3 classes are possible. Again it is the invalid class, less than 17. Again it is a valid class if the age is lies in between 18 to 25. If it is greater than 26, it is also invalid class. And again boundary values, how to write for this one? 17 is the value, 18, 19. 18 is the value. For this we have to write 18 is the value. What is the minimum? Minus 1, 17. Minimum plus 1, 19. Again for this one, 25 is the value, maximum plus 26, maximum minus 1, 24. So this is the way how to solve, how to find out boundary values for one particular value and for one particular class, and also how to find out invalid and valid classes. So this is very, very important point of the problem for your exam point of view. So just you refer this particular examples, and you need to identify valid and invalid classes for one particular problem statement. Maybe for the password, maybe for this type of particular ranges. Also you need to identify the boundary values for this particular values. For 18 is the value, minimum minus 1, minimum plus 1, and 25 is the value, maximum plus 1, maximum minus 1. The question is, what is the nominal values? Whatever the values which are lies in between this condition, that is what we call nominal values. So these are the correct values, whatever you can take from the valid point of view. So these are the what some of the definitions will come under the equivalence partition, the method. The next one, briefly I am going to discuss about component testing. So up to till now what we have studied, unit testing, how to choose one particular unit from the entire set of data. Software components are often composite components that are made up of several interacting objects. So here we are going to provide common interface, that is what we call the component interface. What it is going to, it is act like a bridge. It is going to supply that interface irrespective of their one-to-one correspondence. That is what we call a component testing. For example, in weather station system, the reconfiguration component includes objects that deal with each aspects of reconfiguration. You access the functionality of these objects through the defined component interface. See, you can take a mobile application, you can take any ATM. So we have to provide the common interface in between clients and server, irrespective of their location, irrespective of their function. They can access anything from the retrieved set of data. That is what we call the common interface. Testing composite components should therefore focus on showing that component interface behaves according to its specification. Interface have that some logical specifications. Those specifications will be supplied to client and server, and is irrespective of their particular position. That interface, whatever the value it is supplied, it should be common for all the clients and server. That is what the very important point regarding to the component testing. See, this diagram you will able to understand how the test cases are going to design for component testing. See, these are what we call, these are the some of the types of interfaces. See, these interfaces are common for all the components A, B, C. See, whenever A want to communicate with C, it is going to communicate with these interfaces. Whenever B want to communicate with E, it is going to act as a common interface. C, again, it is going to common interface. They are not directly related to any one of the components. For these are the individual components. So these individual components which are going to connected by using these component interface. That is what we call it. This interface will provide the common bridge in between all the components. Whenever they want to communicate, whenever they want to interact. So this is what we called integration testing. What we call not only interface testing. We are going to integrate all the components, maybe some of the functions, different modules we are going to connect by providing the interfaces, the programming languages. For example, for every Java program which contains some interfaces, so that interfaces, it will provide the services to other members. For example, if A which contains some services, B which contains some services, for example, A want to retrieve the services whatever is held by the B. So what I am going to do, I am going to use this common interface. Again, I want to retrieve I want to access service which is held by C from B. So what I am going to do here, I am going to use an interface. Common interface will provide the common binding, common bridge in between those components. That is what we call the interface testing. Interface testing will help you to provide a bridge in between components and interference. So easily you can share the services, easily you can share the attributes, the methods. For example, some methods which are going to defined at B. So that particular method easily encapsulate by using A. This is what we call encapsulation. So these are the one of the programming aspects which is available at the interface testing. So objectives are to be detect fault due to the interface errors or invalid assumptions about the interface. So these are some of the interface types. One is parameter interface, shared memory interface, procedural interface, and message passing interface. Parameter interface means data passed from one method or procedure to another. A which contains some data value, whenever it is going to pass to the B. So what I am going to use? I am going to use a common interface, that is for passing a parameter. Again, shared memory interfaces means the many of the applications which are going to share the same memory. That is what we call shared memory approach. For example, you can take our DHS software or Contino. There is only one logical partition is going to shared among different clients. You can take your Gmail. Again, Gmail is a single namespace, single memory space. It is going to be used by several clients at the same time. This is what, in that particular moment, the common interface will help you to, identify your own work, identify your own memory area where you people are going to save your particular data in the cloud. That is what we call shared memory interface. Procedural interface means subsystems encapsulate a set of procedures to be called by other subsystems. And message passing interfaces means all the systems how they are going to communicate by passing messages. For example, a client want to communicate with the server. It is going to give send operation. Again, server is going to receive operation. So like that, send and receive operations are going to parallelly, they are going to work by using a message passing paradigms. This is what. So these are the some of the interfaces which are going to available for your software application. One is parameter interface for passing data through the interface. Shared memory means the shared amount of memory is going to consume by multiple clients, that is by using interface, memory interface. Procedural interface means whenever you want to execute something which is held by some other method, that is what we call procedural interface. Message passing means whenever you want to pass something in between two components, we are going to share a message passing interfaces. And so these are the some of the interface errors. One is interface misuse, interface misunderstanding, timing error. Interface misuse means the read and write data should be compatible, okay, with respect to system and their application. Interface misunderstanding, calling component embeds assumptions about the behavior of the called component, whether that particular interface is belong to one particular class is not, or we have to check. Timing error, okay, the writing and reading speed should be compatible. It should be same for two different types of applications. So this is what we called interface testing or component testing. Here we are going to check first what are the different components, how they are going to connect, what is the common interface, particular programming language we are going to use. See, there are a lot of things will be matter. One is programming language, because in software application what happens, there are different types of programming language they are going to use. One particular application, maybe it is written in Python, some application is maybe written in Java, some application they are going to use Android. See, for these all the programs, all these the heterogeneous languages, we have to provide single interface. It should be give the common platform to communicate with each other, irrespective of hardware, irrespective of programming language, irrespective of programmer specifications. Apart from all these things, we have to provide the common interface. So that interface, it should be properly connected to all the system parts. That is what these are the some of the extra points will come under the component test. The diagram is very important. Test cases we are going to design at this stage, and these test cases are depending on these interfaces. The interfaces are with respect to message passing, common memory, and data passing procedures, as well as some of the aspects. See, next I will come to the last one, system testing. So the question is, there are three stages already I told. One is unit testing related with common functions of one particular class or one particular object, one particular operation. But system testing is responsible for checking all the interaction among all the objects what you are going to create it. Here we are going to check all the interaction between those particular functions. Okay, whenever the interaction happen, what results they are going to produce, whether it is correct or not. Calling function and called function, the result retrieval. So these all the things we are going to check. So the basically, in today's era, just we are going to produce the number of versions. You can take a simple operating system, it is going to produce among the different versions. The versions which represents one particular functionality. Version 1 is the basic functionality it is going to provide. Version 2, the next level. Version 3 is the next level. So these versions are going to combine to produce one particular software application, that is what we call system testing. System testing is going to check all the components. Okay, irrespective of the developer is going to from the same company or not. Okay, if the components of what are the different particular type or not, we have to check their compatibility in terms of interaction. Those interactions are correct or not. You can take a ATM example, it is going to connect to different parts. Maybe bank database is one part, again it is going to connect to the central server, to the bank, then to the client. So these all the interactions should be satisfied for functional and non-functional requirements. Functional requirements means what particular function it should cover all the aspects or not. It should it should meet all the customer expectations. That is also one particular thing. Non-functional means emergent properties. It should be secure. It should be the safety, and it should be reliable. So these all the aspects we are going to check by using system testing. The focus in system testing is testing the interaction between the components. In component level, just we are going to check the interfaces, whether they are properly connected or not. But in system testing, also we are going to check connections as well as their working environment, working paradigms. Okay, all the functions which are going to executed correctly or not. So that is what we called system testing. Check the components are compatible, interact correctly, transfer the right data at the right time across their interfaces. System testing tests the emergent behavior of the system. Emergent behavior means not only functionality, again it is going to check non-functional environment, non-functional requirements also. And here the difference between system and component testing. During system testing, reusable components that have been separately developed, off-the-shelf systems may be integrated with newly developed components. The complete system is then tested. Component developed by different team members or sub-team may be integrated at this stage. System testing is a collective rather than an individual process. In component testing and system testing, there is only in component we are going to integrate. Okay, and in system we are going to integrate, we are going to check their specifications also. Integration is different. In systems testing we are going to check their functionality against those integration. Okay, whenever you combine some particular system components, once it is connected, what particular functions results it is going to produce is a one particular system testing the characteristics. So this is what will take one problem statement for your system testing. What exactly the system testing for? We'll take a developer part of an automated teller machine, means our ATM. ATM is a perfect example for system testing. Again, you can take the library management system also, but the ATM is the perfect example. So first we have to create a GUI, graphical user interface. Display a welcome screen with the simple instruction to insert ATM card. We are going to checking validation of the ATM card. If validate, keeps it, otherwise goes on ask for validates the personal ID number. If valid, three activity options are presented: check the account balance, withdraw, deposit. Once the option is selected, the customer is presented with an option to choose between the checking or savings account. For each of these three options activities, the customer account file is also updated with date of the ATM access. Increment the number of times this account is accessed to that particular ATM. See, the system testing means here we have to club all the components. First, authentication is one component, and transaction is another component, displaying is another component. The question is how we are going to combine these three components, and how to integrate these components, how to validate these components, how they are going to interact simultaneously one by one. It should be a sequential manner. Once the ATM card is put into the ATM machine, first it is going to validate the card. If the card is okay, again it will switch to the transaction part. If the transaction is successful, it is going to print and it is going to give the date of transaction, and also it will give the increment the number of times this account is accessed to the ATM. So simultaneously we have to perform all these activities. How these activities are coordinated, whether all the activities are coordinated correctly or not, whether it is going to produce correct result or not. So these all the things we are going to check by using system testing. System testing is responsible for every component and they are combined. When they are combined, how they are going to work as a system, how they are going to produce. If any one of the component is not able to react that particular time, how the system is going to stable, how the system is going to self-optimize, how it is going to self-assessment. So these things which are going to study under the heading of system testing. So this is what the graphical user interface when it is created for ATM system. So this is what we called the GUI. It will produce, it will give you the display, it will give you the welcome screen, and so these are the numbers and different particular components. See, it contains all the components. Whenever I press something here, it is going to process. The interface is responsible for carrying those things. Okay, whenever I am going to give the ATM card I put into the ATM machine, first it validates whether the card is valid or not. If it is invalid, again one particular message is going to give to the user. If it is a valid, again it is going to switch to the transaction. When you go to the transaction, again some conditions we need to check. If the account balance is requested, then the new balance is printed and the customer is given choice for the more activities. For both withdrawal and deposit options, the customer is asked to key in the amount. Here, for withdrawal, whenever you want to withdraw some particular amount from the ATM, what conditions we are going to check? First, what is the maximum amount what we can withdraw at a one particular day? Maybe sometimes 50,000. If you give as a user, when I enter 60,000, it should give the exception, it should give the error. This what we are going to maintain. If the whatever the amount what we have requested, if it is less in our particular account, again this withdrawal option will be cancelled. It is going to give some error. For the deposit, again we are going to check the credential, whether that particular deposit option is there or not. That possibility we have to check. When customer activities are complete, the new balance sheet should be printed. So like that, so these all the components which are going to integrated, and collectively we are going to test these activities. So this is what one of the responsibility for system tester, and testing is a very important activity. So in software development life cycle, so that's why there are a lot of the fundamental basic types are there. So those all the things we have studied, like first one is unit testing. Under unit testing, there are two strategies. One is partition testing, second one is guideline based testing. Again, partition testing, we are going to how to partition the data and how we are going to check in correspondingly in between input and output. That is also one of the important aspects, and some of the examples which are solved. In component testing, how we are going to provide the component interface between several components together. In system testing, how we are going to provide the common interaction, the proper interaction between those components. So ATM example is the best example for your system testing. They may be asked, some of the questions will appear in your exam, like what is the difference between unit testing and system testing. How to define in unit testing, especially the class, the method and associated attributes for one particular class is a very important. We have to check all their operations and we have to simulate the data in all the states. Okay, how it is going to behave, the single component, single object. But when you come to the system testing, it is not an individual operation, it should be collective. Collectively, we are going to check all the system properties, like functional and non-functional properties are going to meet or not. Means functionality means, what is the ATM functionality? It should correctly dispense the money. It should withdraw options. Again, we are going to check all the conditions. Okay. So this is, the system testing is responsible for checking the entirely. There, as a system, how it is going to behave, how it is going to provide the functional and non-functional requirements to meet the customer needs. This is what we call system testing. Again, we can give several examples for unit testing and system testing. Yes, in today's class, what I have covered means, just I will review. And first one, there are three types of testing.